welcome back to a new week of videos. Now firstly, I just wanted to start off by saying that as I'm recording this, we haven't yet had the Prime Minister's announcement, so I'm just going to film this video as if we were carrying on as normal at the moment, working from home. I also just wanted to say that there are still quite a number of you that we haven't heard from yet on the emails, and I'm getting emails every day saying, you know, we're watching the videos, we're finding them really, really helpful. So if you are one of those people that's watching these videos, then great, but we'd also really love to hear from you. Even if you don't want to share any work with us, we'd just love to hear how you're doing and just email to say hello. That would be lovely. So do drop us an email. You can find the email address on the school website. Every year group has one, so just encourage you to get in touch really. This week in maths we are carrying on looking at shapes, and specifically 3D shapes this week. So let's get into today's presentation. Like I said, we are looking at identifying 3D shapes from 2D representations. Now, although that learning objective says from 2D representations, you might find it helpful to have a piece of paper or a couple of pieces of paper in front of you so that you can actually draw out these 3D shapes and make them yourself, so that you've got a better idea of how the faces and the shapes fit together. You'll also find a couple of nets that I've included at the end of the week 6 planning that you're more than welcome to print out and use yourself to form those shapes if they help you. So this is just a reminder of some of the 2D shapes and angles that we've looked at. So in our quadrilaterals, we've got a square, a rhombus, a rectangle, a trapezium and a kite. And a quadrilateral is just a four-sided shape, four-sided 2D shape. That word quad means four. Then if we look at the box on the right hand side, we've got our polygons. We've got regular polygons, so there's a 5-sided pentagon there, there's a 6-sided hexagon, and regular polygons have all sides and angles equal. Then on the other side we've got our irregular polygons, so we've got an irregular polygon with 5 sides. You can see there that not all the sides are the same length. And we've got an irregular octagon. It does not have equal sides or angles. And then there's a little note underneath that a polygon is a plain 2-dimensional shape with straight sides. So a circle is not a polygon because it does not have straight sides, for example. Then if we look on the box on the bottom left hand side, we've got parallel lines there. So an example of parallel lines is train tracks, and parallel lines are straight lines that are an equal distance apart. Then if we look at the next box along, we've just got an example of some angles, a reminder of those. We've got a right angle, which is 90 degrees, an acute angle, which is less than 90 degrees, and an obtuse angle, which is more than 90 degrees. And that specific angle there is also a reflex angle. Then in the bottom right hand corner, we've got reflective symmetry, and a line of symmetry cuts shapes into equal but opposite pieces. So if there is a direct line of symmetry in a shape, it means the same is on both sides. A 3D shape is a solid shape. It has a length, width and a height. This means they can be seen all the way around. The D stands for the word dimensional. And we've got examples of 3D shapes here, so it might be an idea to go around your house after this video and see what kind of 3D shapes you can find in your house. And we've got a cuboid here, a cylinder, a cone, a triangular pyramid, a cube, a square-based pyramid, a sphere, a triangular prism, and a hexagonal prism. Now I just wanted to talk about a couple of the shapes on there for a start. So if you look, we've got two different types of pyramids there. We've got a triangular pyramid and a square-based pyramid. The difference in them is their bases. So if you have a look at the triangular pyramid, it's got a triangle on the base and only 3 triangular faces pointing up to the top of it. Whereas the square-based pyramid has a square on the base, as you would think by the name, and it has 4 triangular faces pointing up to the top of it. The difference between the pyramids and the prism is if you look at the prism, it's got a longer line at the top of it as opposed to all the faces coming up to a point at the top. We can use the properties of a shape to describe or identify it. The properties for 3D shapes include the number of edges, faces and vertices. So you can see there they've labelled the face, the edge and the vertex. A face is the surface of a shape. A face can be curved or flat. An edge is the line segment where two faces of a 3D shape meet, and you can see there that a cube has 12 edges. A vertex, or vertices when there is more than one, is the point where two edges meet, and sometimes we call them corners, but the proper mathematical name for them is a vertex or vertices when it's plural. A net shows what a 3D shape would look like if opened out flat as a 2D representation. So you can see here we've got a square-based pyramid, and on the right-hand side that's what it would be like opened out flat. A net can be folded up to make a 3D shape. You have to identify the faces of the shape. A cube has a variety of different ways it can be represented as a net, 11 ways in total. This is one example, so if this blue shape were to be printed off and folded up all together, it would make a cube. This is an example of a net of a triangular prism. So again, if you had the middle rectangle as the base, you would fold up the top and bottom rectangle to make the sides, and then the triangles would make the other sides. If you've ever had a Toblerone or seen one, then that is an example of a triangular prism. This is an example of a net of a cuboid, and the difference between the net of a cuboid and the net of a cube is that you will have noticed that all the faces of the cube are completely square, whereas on our cuboid we've got a mixture of squares and rectangles. Okay, so now it's your turn to have a go and think about which of these nets would make a cube. This is where you might find it really useful to use your piece of paper so that you can physically make these and see which ones would make a cube and which ones wouldn't. Pause the video here and have a go and have a think about that. How did you get on? Now I'm going to be really honest with you here, I really struggle with this kind of thing myself, so I actually just went and got my own piece of paper and made one of the cubes myself, because I knew that this cube and this net would definitely make a cube, but I really wasn't sure about this one at the bottom in the middle, so I made it myself and it does not make a cube. So the one on the left, the net on the left, and the net on the right are the only ones that would make complete cubes on this occasion. And the next question, Sammy says that all pyramids use a square face and a triangular face like the one he has sketched here. Is he correct? Well, Sammy is actually not correct in this one, because if you remember back to one of the first slides that we saw that there are different types of pyramids. We looked at a square-based pyramid and a triangular-based pyramid, and there are actually lots of different types of pyramids that you can have as well. You can have an octagonal-based pyramid, a hexagonal-based pyramid, so there are lots of different types, so they don't all necessarily have to be square and triangles, but they do all have triangular faces that come together to make that point at the top. And this is a challenge for you if you'd like to have a go. Raj works for a packaging company. They have designed a new box with a special lid. Design a net to create the box like the one pictured here. It must include the 4 parts to the lid. So that's a practical activity. You don't have to do it, but that's just an extra one there if you'd like to do that one. Hopefully that's given you a much better idea of looking at 3D shapes today, and you feel more confident to do today's maths activities. So that's all for today's lesson. As always, answers will be in the description box below, along with a link to find the work and the schools and my Twitter accounts. And if there's anything that you need help with at all, once again, just drop us an email. Thanks for watching, and I'll see you in tomorrow's video. Bye!